Here we go, yo. Here we go, yo. So what's the scenario? Implicit differentiation. So I do a derivative of both sides to find y prime eventually. So if I prime the left-hand side, what do you get? You get a product rule. So let's call this u and v. So u prime is 1. So you have 1 times y. Let's make that bigger. 1 times y plus x times y prime. It's my product rule. On the right-hand side, when I prime that thingamabob, the fractional exponent is going to come down, because I'm going to write this as something to the power of a half. So chain rule. Half comes down. X squared plus y squared minus a half. And then you get the derivative of the inside function. So you get 2x is the derivative of this. And then you get 2y, but don't forget y prime. Again, the y prime pops out because you're doing a chain rule when you find the derivative of y squared. Okay. Now what do I do? What do I do? What do I do? Well, I have to expand out this right-hand side so as to be able to collect my y prime terms. First thing I'll do is I'll notice, quite cleverly, I might add, that this cancels with these 2's here. And then I can expand out the right-hand side, clean up the left-hand side. What do you get? You get this times x to begin with, plus same thing times y prime. Okay, my next step is to collect my terms involving y prime, this guy and this guy, collect them all on one side. Doesn't matter which side you do. Why don't we choose the right-hand side? So this guy will go there, and this guy will go to the right. So we're going to get y minus this term. There's my left-hand side. Right-hand side is, what is it, minus xy prime comes from the left there, and then I get plus y prime, x squared plus y squared, then minus a half. Okay, you'll notice that here and here I rearranged my factors. I put my y prime in front here and my x in front here. That's not really necessary until the end, but I just do it subconsciously. Now I got my y prime terms on the right-hand side, so now I'll factor out y prime. So this is the technique we use to isolate y prime. Factoring out y prime gives me this. And now I can solve for y prime. Oops, there's my next example. Sneaking in there. So I solve for y prime. I get y minus x squared plus y squared, all all over minus x plus y, x squared plus y squared. Ooh, lost my exponents. Very common mistake. Just losing exponents in the heat of battle. And this equals y prime. So what I did was I had this equation and I divided both sides by this rectangle here. Okay, this is a negative exponent inside a fraction. That is a no-no. That's not simplified. So what I'm going to do is I'm going to multiply this fraction, top and bottom, by x squared plus y squared to the plus 1/2. And that will take care of my unsimplified situation. Okay, the issue is technically you have a fraction inside a fraction, which is not good. So my y prime becomes y x squared plus y squared to the plus 1/2 now, minus x, that's not an x, all divided by minus x squared plus y squared plus y. Et voila, there is my y prime. Okay, next. Look at this example. Pause and copy if you need to. Okay. So I'm going to prove this equation. So I'm going to prove my example. My example is to prove this thing. So how am I going to do that? So you assume, well, we should be assuming that b is bigger than 0. Otherwise, these exponential functions get very strange indeed. So what are we going to do? Well, we're going to start with y is equal to b to the x, and then try to find y prime. Okay, and the trick we'll use is to apply the function ln to both sides. So I'll go ln of this side and I'll go ln of this side. So I got ln of y is equal to ln b x. Now I can use my rule of logarithms that you learned in Sec 5, which says that this exponent can come, this exponent can come in front. Okay, now I can do the derivative of both sides. So on the left, I'm going to have a chain rule. You got 1 over y times y prime. Okay, you may find it worth your while to memorize a formula. If I have ln of a function and I do a derivative, it's the same thing every time. It's always f prime over f. Okay, the reason is chain rule, but this thing happens so often that it's worth memorizing. On the right-hand side, rather, we have something pretty straightforward. You have just ln of b, which is a number, times x. Okay, if you had like If you had, 17x, the derivative is just 17, right? So for the same reason, the derivative of this guy is just ln b. Okay, I'm deep in it. I gotta remember what I'm trying to do. I'm trying to find y prime. So y prime is going to be ln b times y. Okay, moving this y up there. And finally, I have to remember what y is. Y is b dx. And that is what I wanted.